A $50,000 car, after 10 years, might look like nothing more than scrap. But what most people don't realize is that over 90% of its materials still hold significant value. Multi-layer windshields and worn-out tires, things we often consider useless, are actually waiting for a second life. In this video, you'll see how engineers separate PVB plastic from glass, shred massive tires to recover steel, and turn them into refined rubber granules. This isn't just recycling, it's industrial-scale material rebirth. Everything begins when the vehicle enters the facility, not to be destroyed immediately, but to be carefully understood. Each car is treated like a material record, its VIN is verified, and its battery and remaining fuel are thoroughly assessed, because even the smallest mistake can create serious risks later in the process. At this stage, the car is no longer just an old vehicle, but a collection of resources waiting to be properly separated. Once the inspection is complete, the vehicle moves into the draining phase, where all fluids, engine oil, coolant, and fuel are carefully extracted to prevent leaks and environmental contamination. With the vehicle now safe, dismantling begins not as destruction, but as controlled separation. From the battery and sensors to the dashboard and interior, each component is removed using manual tools or hydraulic equipment. Every part leaving the vehicle isn't disappearing, it's entering a new life cycle where its value will be used in a completely different way. Once all removable components have been taken out, what remains is a raw structural shell ready for mechanical processing. These frames are placed onto conveyor systems, where automated lines take over and direct materials into specialized processing streams. From this point on, the process shifts from dismantling to transformation, where metals are compacted, rubber is shredded, and glass is separated into layers. This is the moment where the end of a vehicle becomes the beginning of entirely new materials. The process begins as wheels are separated from the vehicle, where mechanical systems and hydraulic presses gradually force the metal rims away from the thick, durable rubber. This is far from a simple task, as tires are engineered to withstand extreme stress and wear over long periods, requiring both force and precision to separate. Once removed, the tires are not immediately processed but are placed in designated storage areas. Here, temperature sensors and monitoring systems run continuously, as large accumulations of tires can pose serious fire risks if left unmanaged. At this stage, everything feels still, like a necessary pause before the process shifts into a completely different phase, where materials will be broken down and redefined. Once the tires enter the main processing line, the atmosphere shifts dramatically. Massive tires are pulled into powerful shredders, where rotating steel blades tear through their dense structure with relentless force. The sound of grinding metal and snapping rubber creates a raw, almost rhythmic intensity. In more advanced systems, this process is enhanced by cryogenic technology. Liquid nitrogen rapidly lowers the temperature, making the rubber brittle instead of elastic. Rather than stretching, it fractures into sharp, clean pieces, allowing for more efficient and precise processing. This is the true climax of the entire line, the moment when old material is completely broken down, ready to be reshaped into something new. After being shredded, the material enters a separation phase where precision takes over. Powerful magnets extract steel from the moving stream, while vibrating screens continuously sort rubber particles by size. Beyond that, additional filtering stages ensure the final material meets the purity required for reuse. Gradually, what was once a chaotic mass of tire fragments becomes uniform, stable rubber granules. From 1 ton of scrap tires up to 700 to 800 kilograms of crumb rubber can be recovered, a clear indication of the hidden value within what we often consider waste. And this is not the end of the journey, but the beginning of another, where these granules are used to create stronger, quieter roads, becoming part of everyday life in ways we rarely notice. Unlike most materials, windshields are not just glass, they are complex composites made of two glass layers bonded with a flexible PVB plastic layer for safety. This makes recycling significantly more challenging. At the start, technicians cannot simply shatter them. Instead, they carefully remove the glass using specialized cutting wires and vacuum suction tools to stabilize the surface. Every movement is controlled because the goal is not immediate destruction, but preserving the structure long enough for precise processing in the next stage. Once removed, the windshields are not immediately processed. Instead, they are gathered and stacked in designated areas. Hundreds, sometimes thousands of glass panels are piled together, forming massive volumes of material waiting to be processed. This is not just storage, it's about preparing a consistent input flow for the system ahead, ensuring smooth and continuous operation. At this stage, the atmosphere shifts from detailed manual work to large-scale industrial preparation. Once inside the processing line, the layered structure is finally broken apart. Rotating crushers begin to separate the bonded layers of glass and PVB plastic. Unlike tire shredding, this is not a chaotic process, it's a controlled balance of force and precision. After crushing, the material passes through vibrating screens and air separation systems, where the lighter plastic is lifted away from the heavier glass particles. Step by step, the process unfolds smoothly and systematically, turning a complex structure into distinct components. But before entering the main processing stage, these massive stacks of glass are not fed into the crushers right away. Instead, they are gradually moved along large conveyor systems, where the flow of material is carefully regulated, adjusting speed, balancing volume, and ensuring a consistent input into the line. The stacked glass panels begin to shift, lightly colliding with one another, producing sharp, rhythmic sounds. This is a critical transition moment when a static mass of material becomes dynamic, preparing to enter the stage where its structure will be completely broken down. But true rebirth requires more than separation. The glass particles are sent through advanced cleaning and optical sorting systems, where laser sensors and high-speed cameras scan each fragment. Any impurities, metal, paint, or debris are instantly detected and removed using precise air jets. After being cleaned and fully separated from impurities, the glass fragments enter the most critical stage, melting. They are mixed with silica sand, limestone, and soda ash, then gradually fed into massive industrial furnaces where temperatures rise beyond 2,500 degrees Fahrenheit. Inside, everything transforms. The sharp, rigid fragments begin to soften, dissolve, and merge into a glowing geryon of molten material, radiating an intense orange-red light like liquid metal. No original shape remains, no cracks, no imperfections, only a continuous flow of purified glass, moving under extreme heat. From the furnace, this molten glass is guided out and poured onto a bath of liquid tin in the float glass process. Here, gravity and surface tension spread it into a perfectly flat, mirror-like layer. As it cools, the glass is drawn forward, precisely cut, and shaped to exact dimensions. But the transformation doesn't end there. The sheets are reheated, curved into form, and laminated with a new PVB layer, restoring the safety structure of a modern windshield. From shattered fragments once considered waste, they return as something entirely new, ready to become part of the next generation of vehicles. But even after the glass has been fully formed, its journey is not over. Before leaving the facility, each sheet undergoes a series of rigorous quality checks testing clarity, surface consistency, strength, and impact resistance. Light is passed through the glass to detect even the smallest imperfections, while mechanical tests simulate real-world conditions it will face on the road. Only those that meet the highest standards are allowed to move forward. From there, the glass is transported to automotive factories, where everything happens with near-perfect precision. Robotic arms position each windshield, apply specialized adhesives, and secure it into new vehicle frames with almost zero tolerance for error. In just a few seconds, the glass becomes an inseparable part of the car, not just a material, but a critical safety component for the people inside. And then, the most remarkable moment happens quietly. What was once a shattered piece of glass, discarded and forgotten, now sits on a brand new vehicle, ready to return to the road. No one sees the journey behind it. No one realizes it was once broken, melted, and reborn. But that's what makes it powerful, because in the modern world, what seems like an ending is often just the beginning of something new. From discarded tires to shattered pieces of glass once thought worthless, everything has gone through a journey few people ever see. A journey of force, heat, and technology, where materials are broken down, separated, and rebuilt from the ground up. But the real story isn't just about machines or processes, it's about how we choose to see waste. Because in the modern world, nothing truly disappears. What we throw away is simply waiting for a chance to return in a different form. A tire can become the road you drive on every day. A broken piece of glass can become the shield that protects you on the journey ahead. And perhaps the most powerful idea is this: the future isn't built only from new resources, but from what we once left behind.